Today we're going to be talking about conditional statements. You're going to learn what's a conjecture, what's a counterexample, what are a conditional, and all of its related statements. Inductive reasoning is just a process that includes looking for patterns and making conjectures. So what's a conjecture? A conjecture is an unproven statement that is based on observations. For example, if you have homework every night in geometry, what's going to happen tonight? Well, you should expect that you will have homework. Okay. If it has rained for the past 3 days, what do you think is going to happen today? Well, it will rain. Of course, we have had a heat wave for the past week, it seems like, or Monday at least. Hot, hot, hot. We would expect it to be really hot again tomorrow. Although the weather prediction is that it's not going to be so hot or as hot. So it's unproven, and it's more likely to be true than not, but not necessarily, just like the weather. So to prove a conjecture, you must show it works for all cases. That's kind of hard to do, right? That'd be a lot of proving. Would have to look at every day, and you just couldn't do it. So what you can do is you can disprove it by showing a counterexample. And a counterexample is just a specific case that shows that a conjecture is false. So if I'm going to find a counterexample, if the product of two numbers is positive, then the two numbers must both be positive. So remember, product means to multiply. So if our product is positive, then the two numbers must also be positive. Well, that's not true, right? Because if I multiply -2 times -5, that will give you a +10. So there's your counterexample to disprove this statement. Okay. The product of a plus b squared is equal to a squared plus b squared. Hopefully you remember from Algebra 1 that we have to write this out as a plus b and a plus b. So if I use FOIL, the box, whatever method you use to multiply, I'm going to get a squared plus ab plus ab plus b squared, or a squared plus 2ab plus b squared. So there's your counterexample. If you wanted to, you could also actually put in real numbers and let it work. If you let a be 5 and b be 2, okay, so you would have 2 plus 5 squared, which would be 7 squared, which is 49, or 5 squared plus 2 squared, which is totally different because it is 25 plus 4, which is only 29. So we've just disproved it or provided a counterexample both algebraically and numerically. Now, a conditional is a logical statement that has two parts. It has a hypothesis and a conclusion. Okay? It's another word for it is an if-then statement. Okay? So, for example, if it is 7th period, then you have geometry. This is my hypothesis, the if part. This, you have geometry, is the conclusion. So if I want to write a statement in an if-then statement, we would get rid of the all and we would say if an animal is a whale, so we got to state a little bit more. Then it is a mammal. All right, first I move it on. So 3 points are collinear if they lie in a line. Okay. So if 3 points are collinear, then they lie on the line. This is the hypothesis. 3 points are collinear. This is the conclusion. So just like with set theory, we have symbology with conditional statements. We usually say that P is the hypothesis, Q is the conclusion. This means that it indicates a conditional statement, that arrow going that way. A tilde, or this little mark here, negates a statement. And these 3 dots mean, therefore, a final logical statement. So if we're talking about an if-then statement, it's P, then Q. A truth value just is a conditional, just says, hey, it's true or false. That's all a truth value is. So for a conditional to be true, though, both its hypothesis and its conclusion has to be true. So we're talking like logic here. So this can get a little confusing. So is this conditional true or false? And if it's false, let's find a counterexample. If a month is February, then it has 28 days. Well, I can find a counterexample. Okay, because there is leap year that has 29 days. So that would be a false conditional. Okay. If 2 angles form a linear pair, then they are supplementary. So we haven't really talked about this much this year because we kind of reordered things. But a linear pair means that they lie on a line. Okay. A line is 180 degrees. So yes, they are supplementary. So this truth value is true. So now we have related statements. So here is my conditional. If it is raining, then the sky is gray. My hypothesis is it is raining. My conclusion is the sky is gray. My converse switches the hypothesis and the conclusion. So instead of if P then Q, it's going to be Q then P. So if the sky is gray, then it is raining. So all we've done is switch those. An inverse takes the original conditional and negates both the hypothesis and the conclusion. So remember, both of these are negation signs. So our inverse is if it is not raining, then the sky is not gray. Contrapositive, if it is raining, then the sky is gray. So what we do for the contrapositive is we negate the converse. So we switch the hypothesis and the conclusion, and we negate it. So my hypothesis, my conclusion, we switch them, and we negate them. So if the sky is not gray, then it is not raining. All right, so if 2 lines intersect to form a right angle, then the lines are perpendicular. So my converse Remember, my converse is Q then P. So if two lines are perpendicular, and we can use symbols, I don't care, this means perpendicular. If two lines are perpendicular, then they form a right angle. Okay? The inverse, we take the conditional and we negate it. So it's the not P, then not Q. So if two lines that intersect don't form a right angle, then they are not perpendicular. Okay. The contrapositive takes the converse and negates that. So if two lines are not perpendicular, then they don't form a right angle. Okay. So there they are, nicer and neater. All right, so I have actually thrown a lot at you today. So you need to know how to write a converse, an inverse, a contrapositive, a conditional. You need to understand some stuff with inductive reasoning. Believe me, I will give you the opportunity to practice in class. So have a math-tastic day.